So number 7 then from paper 2 of the 2016 new hire. Here we go, optimisation, 9 marks. We've seen this before in a previous hire a few years back. Whatever it says, there's rectangle, each rectangle measures x by y. The area of this land is 108. I'll just take a note of that because that is the other piece of information you'll need to connect the variables, because what you really want is what's the total length of fencing. So L, the problem is just now that total length will be expressed in terms of x and y, in terms of two variables. That's why here it says show L solely in terms of x equals that. You could say this, but you tend not to do that, just at a higher level. LXY equals, so what's the total length of the fencing? Well, each of these segments is of length x, and you've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So you've got 9 lots of x. Each of these is of length y, so you've got 8 of those. The problem is you've got x's and y's. It's a function of two variables. You have to make it a function just of x, so I need something else that'll connect x and y, and that's where this area comes in. You know, the area is going to be of the whole thing. It's 3x in its length times 2y for its breadth. So the area equals 6xy and it equals 108. So now you can replace the y. That would rearrange to read y will be 108 over 6x. Feeding that back into the original one means the original one will now be just in terms of x as it states. So that will be 9x plus 8 times this. 8 times 108 over 6x. I'll just put a wee dot there. It is a calculator, you can just use your calculator of course. Well, that would go down to 3 and that would go down to 4. Then 3 goes into this one, so there's nothing left underneath the numbers. Was it doing 3 into that would be 36. So you've got L of x is 9x plus 4 times 36 is 144 over x. And that would be 3 marks. You could always put here, if you felt like it, as required. And part B, find the value of x that minimises the length of fencing. Right, that's the standard optimisation one then. So the first thing is differentiate it, but before you can do that, that's not suitable. So you'd have to rewrite that as plus 144x to the negative 1. Separate terms with the variables in index form. Now we can differentiate it. So that would just go to 9 and then negative multiplying by negative 1 minus 144. 1 off the power drops to negative 2. But I'm going to be using this, so I'm going to finish it off by writing this term properly. As negative means it's down below and squared. So that's L dashed x, which would probably be 2 marks worth, one for putting it to a suitable form and one for differentiating it. Then the statement. We're looking for an optimum value or a stationary value. That means the derivative should equal 0. That's probably worth a mark as well, which means that that expression should equal 0. Now it's just a case of solve this equation. Fractions, get rid of the fractions, multiply everything by x squared. 9x squared minus 144. Because as soon as you do that and you want to write equals, you can just change that into an equals. Right, I'll just carry on this way. So I think I'll double this one. Take the 144 over and divide by 9. Now what you've got is a couple of perfect squares there, but also that divides in. So that would go in 16 times. Now do I have to write square root? I've said it now, which means x equals, I've already done that here though, x equals 4. And the reason is x has to be greater than 0. Now that's not at this part, it's actually this part with the square root. A square root is always positive. If you wanted positives and negatives, you have to put it in here before the square root was done, plus or minus the square root. Ambiguously put it at the side, x is greater than 0. But need to justify it. So for x, pick a number before, pick a number after. You shouldn't pick 0 because x can't be 0, so pick something like 1 and 10 and find what L dashed x is. It's obviously 0 at 4 because that was the whole point. You solved the equation to make that happen. At 1, here's the expression here. 9 minus 144 is clearly negative. At 10, that becomes 100. So you're only subtracting 1.44 from 9. So that's clearly positive, which means it looks like this, as expected, because it did say that, which means you can now make the statement, you've got a minimum length at x equals 4, and I'll put the units in, meters.